In this video, I was focused on data header in a classic 5-stage pipeline, especially RAW header, how forwarding helps, and why load use header can still cause stalls. First, let's look at the data header. In a 5-stage pipeline, we have IF, ID, EX, MEM, and WB. Here is an example. An instruction I2 needs to read S0, but S0 is the result produced by I1. This is the RAW header, which stands for read after write. The key problem is timing. I1 does not write S0 back to the register file until the WB stage, but I2 wants the value earlier, typically when it reaches EX, so without any special hardware support, the pipeline must stall. That's why you see these bubbles, means empty cycle insert to wait until S0 is actually available. Stalls increase the total cycle and reduce performance. Now, to reduce these stalls, we use forwarding, also called bypassing. The idea is use the result as soon as it is computed. Don't wait for write back. In the add instruction, the ALU result is produced in the EX stage. Instead of waiting until WB to store into the register file and then reading it again, we can directly forward that ALU result to the next instruction's EX stage input. So for add followed by sub, forwarding can provide the correct S0 value to the sub instruction in time, which reduces bubbles and improves performance. However, forwarding requires extra data path connections like addition, multiplexers, and control logic, because the CPU must decide where the operand should come from, the register file, EX memory, or memory WB pipeline register. But forwarding does not solve everything. A classic counterexample is the load use header. For example, here I2 needs S0, but S0 is coming for a load instruction. The important difference is the loaded data is not available right after EX. It's become available only after the MEM stage because memory access happens there. So even if we have forwarding, we cannot forward a value that doesn't exist yet when the next instruction needs it. In a 5-stage pipeline, the sub instruction needs the operand in its EX stage, but the LW instruction produces the data at the end of memory. That timing mismatch forces at least a 1-cycle stall. So we insert a bubble. Then the data can be forwarded from memory right back to the sub instruction and execution continues.